Today's topic is rotations in the coordinate plane, and you can use the date of May 6th. These are the first 3 pages of your note packet, and the last 2. The rotation is our 4th transformation in the coordinate plane. And basically, we are taking our point, our line segment, or our figure, and we are rotating it or turning it about a fixed point. We call that fixed point the center of rotation. When you plot your pre-image and your image, you can potentially draw rays from both of those points, and you can locate your center of rotation, and then you can measure the angle of rotation. So that's what we're seeing in the diagram. They have rays from A and A prime to the center of rotation, and they're measuring that turn as 120 degrees. When we abbreviate a rotation, we use a capital R, and this is why we don't use the capital R for reflection, we use the lowercase. In subscript, you put down the amount of turn that you're going to rotate the object. And the second option, if you want to rotate the object around a point that is not the origin, you need to list that specific point. So this would be point A, and then we would rotate it 180 degrees. With a rotation, all rotations are going to be counterclockwise unless they tell you otherwise. We're going to learn to recognize the direction based on the value that they put in the subscript. So positives and negatives should tell us which way to turn the figure. They sometimes abbreviate counterclockwise as CCW, so just keep that in mind. In my image, I have the triangle ABC in black, and it was rotated 90 degrees counterclockwise. If you recall, counterclockwise is moving against the hands of the clock. So basically, I'm turning to the left. So it looks like the triangle in black was turned to the triangle in red. When you turn 90 degrees counterclockwise, that is the normal direction that we rotate in math. So we're going to abbreviate that with a positive 90 because we're going in the correct direction. Now, rotations have general rules. We do have several rules already, so if you can remember it, great. I end up turning my paper. So what I'll do is I'll plot the original figure here in quadrant 1, and then I'll actually physically rotate my paper 90 degrees to the left, and then I reorient my thinking. I look at what is now the x-axis and the y-axis, and I make a list of ordered pairs. But the rule that works for a rotation of 90 degrees counterclockwise says take your generic point P. It will map itself to P prime. Y is going to slide forward and be negated, and X is simply going to slide back. So we're going to try example number 1. We have quadrilateral ABCD that we're going to plot in the coordinate grid. Remember, you can pause the video if you want to work ahead. And there's our rectangle. Make sure you label all the vertices ABCD. The notation says to rotate ABCD 90 degrees. The positive 90 says it's going to go counterclockwise to form our prime image. I'm going to apply the rule. So for A, Y is going to slide forward and be negated, and then X is going to slide back. I'm going to do that with B. Y slid forward and was negated. X slides back. And then we have C prime and D prime. And don't forget to write your rule above the mapping arrows. Now that I know the locations of the prime image, I'm going to go ahead and plot those. So you can see that we turned the red rectangle to the left. The figure also is not standing up in portrait mode. It's now laying in more of a landscape mode. So keep in mind that the figure rotates as we spin it around the origin. Now, 90 degrees clockwise. If you turn it with the hands of the clock, we are moving towards the right. You can see in my image, the original triangle ABC is in quadrant 1. We're turning it to the right, so now it's in quadrant 4. Because we're going clockwise, and this is not the norm in math, we abbreviate it with a negative 90. So negative is bad, I'm going in the wrong direction. We also have a general rule for rotating 90 degrees clockwise. So this time y is going to slide forward, but then x will slide back and become negated. So in example 2, we're going to go ahead and plot rectangle ABCD. This is the same as example 1. And now the instructions say negative 90 degrees, so I'm moving it to the right. So it should end up in quadrant 2. So if I follow the rule, it says y will slide forward, x will slide back and become negated. I'm going to do the same with B prime and C prime. And then with D prime, we're going to write our rule up above the mapping. Please make sure on your homework you do a full mapping. And now that I know the locations of my prime image, I'm going to go ahead and plot those 4 points. And it does, in fact, end up in quadrant 2. Make sure you label your vertices and put your prime notation on. And again, you can see that the rectangle has been turned as we spin it about the origin. Now, if you want to rotate your image 180 degrees, the original figure was here in quadrant 2. The image ended up in quadrant 4. We've actually already done a 180-degree rotation. We just called it a point reflection through the origin. So we're already familiar with this rule. If you look at the ordered pairs for B, we were at -4, +3, and now we're at +4, -3. The abbreviation is capital R for rotation, and 180 degrees is always listed as positive. Even if you list it as negative, it's still going to end up in the same location as if you rotated it to the left or the right. So the general rule says take your generic point P. To find P prime, we will negate both the X and the Y. For our last image, it says that the use of the grid is optional. So I'm going to choose not to use that. And I'm going to rotate my rectangle 180 degrees. So the rule says we're going to negate X and negate Y. So A prime will be located at 3, 1. We'll do the same for B, located at 3, 6. C prime, 6, 6. And finally D prime, 6, 1. And then don't forget your rule up above. In the final example, we're still working with rectangle ABCD, and the use of the grid is optional, but they're asking us to rotate -270 degrees. So negative means I'm going in the wrong way. The original figure we know was here in quadrant 3. So it was graphed in here. If we go 1, 2, 3 turns in the wrong direction, which is to the right, couldn't we make that more efficient? And instead of making 3 turns to the right, wouldn't it be easier to just do 1 turn to the left, which is going against the hands of the clock? So we want to think smarter and work smarter when we're working on these rotations. So this is equivalent to a rotation of 90 degrees counterclockwise. And we have already applied this rule. So I'm just going to go ahead and bring up the points. I did use the correct rotation rule of -270 degrees, the way they described it in the problem. And you should do the same as well. So let's look at some invariant properties, things that do not change when I rotate an object. You can see from our examples that the size of the figure was preserved. I actually created an image that was identical. The shape of the figure was also preserved. That's a good indicator if I made a mistake graphing, if the shape looks different. Angle measure is preserved. We still had 4 right angles. The distance between points was preserved. So if the lengths of the sides were 3 blocks, on my image, those same corresponding sides were still 3 blocks. And any sides that were parallel prior to the rotation are still parallel after, and any points that were collinear prior to the rotation are still collinear. So therefore, that tells us that when you rotate a figure, the original figure and its image are going to be congruent. So that classifies a rotation as an isometry. It's a rigid motion, preserving the original figure when it creates its image. Because the figure itself is turning, we have to say that a rotation is a non-direct isometry. We were not able to preserve orientation, and now your object faces a different way. Your homework tonight is homework number 123. There should be 3 pages. Make sure with problems, looks like 5 through 10, you do a complete mapping. And in 29, you're also doing a complete mapping. Do not start over with the original points. Keep building on to your prime images to finally create the triple prime. If you have any questions as you go through the assignment, please contact me. Otherwise, have a great day.